Greetings, hello, welcome. Let's have a look, or shall we say, a further look at rational functions. Rational. What going on here? Yeah, let's have a further look at rational functions. Okay. Work with me, computer. Yes, now we're talking. Rational functions. So, further look at rational functions. In the previous video, we discussed that, or we found out that a rational function is a function that has a numerator and a denominator, and we defined it as a ratio of two polynomials. A ratio meaning a fraction of two polynomials, whereby one polynomial was a numerator and the other was a denominator. One thing that I didn't explain was what a polynomial was. Right. Normally in textbooks you will find the following format as a standard for polynomial: a n x to the power n minus 1 plus what am I doing? No, it's not like that. There's no minus on this one, so it's a n minus 1 x to the power n minus 1 plus 1 2 3 continuation a1 x plus a0. So this is more like a general format of a polynomial. Don't get confused by it. In case you are wondering what a polynomial is, don't be confused by this, okay? Just know that if you have ever seen a function of this order, it's a 2x squared plus x minus 2. By now, when you see this quadratic equation or quadratic expression or quadratic equation, if I equate this to a 0, comes to your mind, yes, you are right. A quadratic equation or a quadratic expression is a polynomial of the degree of order 2. So you see, the highest variable's degree is of the order 2, so it's a polynomial. And then probably from here we go 1 degree higher, we get something like, we get x to the degree 3 plus x 2. Now the following x squared becomes the lesser degree from degree 3, and there you have your x minus 2 goes to 0. So this is a polynomial of the degree 3. Then we can go even further to the degree 4, and you have this one. It just decreases in that descending order, so it normally won't always be in this case, but this is generally how polynomial looks like, or should be. This is exactly what that general format is telling us. Okay, x squared plus x minus 2. So if you've ever seen a quadratic equation or a cubic equation, or even a linear equation, Remember, a linear equation is of the following order: x plus 2 equals to 0. This is also a polynomial of the degree 1. Can you believe it? Yes, it is. And if you've ever seen, what about the constant? What about 2? Well, wow, yes, you've guessed it. 2 is actually also a polynomial. But what order is it? Well, that's the thing. The variable x is not here because it's of the order 0. And we know from the laws of indices that anything raised to the power 0 is equals to 1. So we have 2 there because it's multiplied by x raised to the power 0, which is the same thing as 1. 2 by 1 is just 2. So 2x to 1 is the same thing as just the constant 2. So wait, what am I saying? Exactly, that's exactly what I'm saying. So a constant is also a polynomial. So there you have it, just a little explanation about what polynomials are, okay? Yeah, cool stuff. I'll just do this, work with me. Okay, so exactly, so we're talking about rational functions, and we found out that they are actually ratios of polynomials. It has a numerator and a denominator. So let's look at examples of rational functions. Example 1, we'll have an example, let's call it f of x. F of x, where the numerator's degree is higher than the denominator. Say x squared plus 1 divided by x plus 2. This is a rational function. Reason being, it has a numerator and it has a denominator. But in this case, the numerator's degree is higher than that of the denominator. As you can see, it's 2 and this one is 1. So that one is a quadratic, the numerator is a quadratic equation, and the denominator is a linear equation, okay? More like a linear expression and a quadratic expression. Okay, example 2. Second example, we'll call it g of x. G of x, whereby the numerator, well, unfortunately in this case the numerator's degree will be lower than that of the denominator. Therefore, it's still a rational function. So yes, this is still a rational function. Only in this case, the numerator's degree, the order of the numerator, degree order of the numerator is less than that of the denominator. So this one is 2. So it's still a rational function, and that one is 1. Okay. Hopefully by now this is starting to somehow sink in. 3. Y of x is equal to, let's say, 1 over x plus 2. Okay? Still a rational function. Why? Well, it has a numerator and a denominator, so it is a rational function. But let's describe it even further. In this case, we have a constant as the numerator, but we discover that a constant has a variable x raised to the power 0, which means it's actually also a constant, is also a polynomial. So this is a ratio of 2 polynomial, whereby the numerator's order is lower than that of the denominator. In this case, the degree of the numerator is 0 and the degree of the denominator is 1. Therefore, we have a constant and then a linear equation. So it's still a rational function of, well, it has a constant as the numerator and the linear equation as a linear expression as the denominator. So 1 over x plus 2. Okay, so let's do one last one, the fourth example. Fourth example would be, let's say, j of x. J of x would have something x plus 1 over x plus 2. Looking at this, they are both linear linear expressions. Both the numerator and the denominator are of the degree 1. Is it still rational function? You bet, definitely it's a rational function. So there we have it. So that's exactly what this is exactly what rational functions are. Come again and let's look at how you plot rational functions. Let's look at vertical asymptotes. Let's look at horizontal asymptote, slanted asymptotes or oblique asymptotes, and and many more. The domain of these type of functions and as well as the range. So I look forward to seeing you to the next video.